Welcome to my workshop. I'm Jim. Today I'd like to show you the procedure I use to make my own printed circuit boards. I use blue toner transfer paper made by a company called Pulsar, which is readily available from DigiKey, Mouser, and other suppliers of electronic components. You'll see this paper described as fab in a box. You'll also need a laser printer, a laminator, and some ammonium persulfate. My procedure is ideal for single-sided boards to be used for prototyping or hobby circuits. I get consistent results with traces as thin as 20 mil or 0.02 inches. It's easy to add a silkscreen layer, and the final product is quite respectable. I use two different programs to lay out printed circuit boards, 123 Express and KiCad. Both are available for free on the internet. 123 Express is easier to use, and it's ideal for single-sided boards. KiCad is much more sophisticated, but it has all the features you need to make the most sophisticated multi-layer boards. If you're just starting out, start with 123 Express. For this tutorial, I'll prepare a board for this circuit, which I drew up in 123 Express. The board is 5 1/4 inches wide and 4 1/4 inches high. The first step is to cut a piece of board to the right shape, so print your layout at 1:1 scale onto a piece of standard white paper. At this point, only the outline of the board is important, so it doesn't matter whether you print the copper layer or the silkscreen layer. Cut out the pattern and glue it to the PC stock from which the board will be cut. If the outline is not a simple rectangle, then make sure to glue the cutting pattern to whichever side will leave the board with the right shape and with the copper on the right side. A glue stick is perfect. It has just enough moisture. Too much moisture in the glue can allow the pattern to stretch while it's being glued down. I then use a hacksaw to cut out the board and a sanding block to round the edges and corners. Cut as precisely as you can. A well-cut board will make it easier to line up the silkscreen pattern at a later step. The copper side of the board needs to be well cleaned. I use a scrubbing pad and cleaning powder made for pots and pans. It's best to use a powder which is designed for copper pots and pans. I happen to use powder made by Lagostina. The label clearly specifies use on copper, but I don't think there's anything special about the brand name. Use the hard side of the scrubbing pad and scour until clean. I use a circular motion simply because it's easier to stay within the confines of the board. Scrubbing will leave some very light scratching on the surface, which can be seen when the board is held up at an oblique angle to a light source. The scratches neither help nor hinder the adhesion of the toner to the copper. Do not use steel wool to clean the copper. Small particles of steel can detach, and they will interfere with the action of the etchant. Shake off all excess water and stand the board on its edge to dry. As the water dries, it will discolor the copper. I've not found that to be a problem. Do not use a paper towel to dry the board. Paper, or even cloth for that matter, contains various chemicals which will contaminate the surface. In fact, it's best not to let anything touch the copper. To hurry things along, I often blow the board dry with a heat gun, but that's not essential. In the next step, we'll print the copper layer of the layout onto another sheet of standard white paper. You likely drafted your layout looking down from the top, with the copper traces on the bottom of the board. If so, then do not mirror the image before printing. Let it print out in reverse. Center the image in the middle of the page and print at 1:1 scale. The printed image must include the outline of the board. Before printing, pencil in a small arrow at the top right corner of the blank paper. Use the manual feed slot on the printer. If your printer has a hatch on the back to allow paper to exit it back without folding the paper back onto the top of the printer, then open the hatch. Using the manual feed input and output slot allows the toner transfer paper, which is pretty thick, to travel through the printer while it's flat, without the stress of being bent hard over on the way in and once again on the way out. Note that I printed this layout in landscape mode, not portrait mode. The layout I designed is wider than it is high. I want the narrow edge of the blue paper to be the leading edge on the way through the printer, so I selected landscape mode. Cut out a piece of the blue toner transfer paper about a ½ inch or so bigger around than the outline of the board. Tape this piece over the image on the white paper. The shiny side is the front. It's the side you want to print on. Do not use any kind of tape which is made of plastic. It will melt inside the laminator. I found the best tape to be one called painter's tape. Painters use it to mask exclusion areas. It's very thin and feels and tears just like paper. This blue roll is made by 3M. The inside label describes it as multi-purpose painter's tape number 2090. It's available at all kinds of paint and hardware stores, among them Home Depot. Note that the 3M brand name is now owned by the Scotch Company, so the packaging may also show the Scotch name, but this tape is certainly not what one thinks of as Scotch tape. Apply 2 or 3 small pieces of tape along the edge, which will be fed first into the printer. The arrow you penciled in before points to this top edge. Be sure to reinsert the paper back into the printer in the same orientation as before. At all times, take care not to touch the shiny blue side of the toner transfer paper. After printing, carefully cut out the toner transfer paper along the outline. Take care not to let anything touch the shiny side, including your fingers. The board must be completely dry before we use the laminator. Any drops on the surface will destroy the toner transfer paper. Tape the transfer paper to the board. The shiny side of the paper goes against the copper layer. Decide which edge you want to go through the laminator first and put the tape along that edge. It's always best to feed the board with the narrow side across the rollers. 2 or 3 pieces of tape will be enough. To the extent you can, position the tape so that it is not over top any of the copper traces. This is the laminator. It has 2 rollers inside, which are heated and squeezed together. As the rollers pull the board through, the heat melts the toner, and the pressure causes it to adhere to the copper. The temperature and the pressure need to be as high as possible. This lever here can be pulled up to ease the pressure between the rollers. I sometimes push the lever down the wrong way in order to increase the pressure. In fact, when I first got this laminator 15 years ago, I used an X-Acto knife to carve out the bottom lip of the hole so that I could push down on the lever even more. I also removed the cover to get access to the gear mechanism at the end of the rollers. With a screwdriver, I adjusted the spacing of the roller axes to tighten them together as far as they would go. The laminator takes a few minutes to heat up. I usually turn it on back when printing the layout so that by the time I'm ready to use it, it's already piping hot. Insert the board in the middle of the rollers, not near either end. I keep this little push stick handy in case the board gets stuck. This board is 1/16 of an inch thick. The toner transfer paper is quite heavy, and the combination of the two is thick enough that the drive gears may be displaced far enough that the gears skip a tooth. The push-down lever and the push stick help the board pass through rough patches in the transit. When the board comes out, it will be very, very hot, but it can still be lifted with fingers held on the edge. Peel off the pieces of tape, then run it through the laminator again. I usually run it through the laminator 4 times, and then I pass it through from the side, with 2 passes for each side. As I said, the board will get very hot, and you'll have to hold it like a hot potato. Multiple passes through the laminator ensure that the board reaches as high a temperature as possible. It may be that my practice of running 8 passes in total is a bit of overkill. However, since my procedure works consistently and well and doesn't take too much extra time, I've never been tempted to see how well fewer passes might work out. Now let the board cool down. Once it's down to just warm, drop it into a tray of clean water. This is where the toner transfer paper really shows its value. After a few minutes in the water, the paper will simply slide away, leaving the toner fixed to the copper. The adhesion is very good. It's possible that there was a speck of dust somewhere on the board when you taped the toner transfer paper into place. If so, there might be a speck of toner at that point. To get it off, you'll have to use the point of an X-Acto knife to scrape it away. Before proceeding to the next step, I thoroughly wash the board again, this time using the soft side of the scrubbing pad. Set it upright on edge to dry, or use the heat gun. As always, don't let anything touch the board. Although the only copper which can still be seen is going to be removed, any grease or contamination will hinder its removal. Once the board is completely dry, it's time to add a layer of green. This green sheet is not toner transfer paper per se, but it's made by the same company and is sold alongside the toner transfer paper. They call it foil. The green foil is a thin layer of mylar on which some very fine particles have been deposited. These particles are like dust or talcum powder. The shiny side is the mylar, the matte side is the dust. Cut a piece of green foil about an inch bigger all around than the board. Tape it to the board using the painter's tape. I find it best to fold the mylar over the edge, which will be inserted into the laminator, and to put the tape on the non-copper side. This assembly will now be run through the laminator. I found out early on that this laminator set at maximum temperature will melt the mylar and create an unusable mess. Through trial and error, starting at low temperatures and working up, I determined that the highest temperature for running the mylar was when the temperature dial was set to 0.8. It will take a few minutes for the laminator to cool down to this lower temperature from the maximum setting used on the blue toner transfer paper. I usually dial the temperature down to this new setting as soon as the toner transfer process has been completed, so by the time I'm ready to do the mylar, the laminator is ready too. Once the board is inserted and the rollers grab it, I hold the tail ends of the mylar to keep it stretched out as smoothly as possible. When the board comes out, the mylar will have adhered to the copper which is still exposed on the board. I remove the tape and then reinsert. I usually run the board through the laminator 4 times. After each pass, you'll see more adhesion between the mylar and the remaining copper. For the green foil, I don't run the board through from the sides. Now let the board cool. There's no need for water this time. Once the board is cool to touch, the mylar can be peeled off. The heat and pressure will have melted the toner again and allowed the green dust to become embedded in the toner. What's the purpose of the green dust? It fills the microscopic holes which are left in the toner deposited inside the printer. This board is now ready to be etched. I drill one hole through the board using a 1/16 inch bit. Which particular hole doesn't matter, but I pick one near a corner, perhaps where a mounting bolt is going to go. I run a piece of hookup wire through the hole and twist the ends together. I use this wire for lifting the board out of the etching. And now for etching. I use this etching tank, which is specifically designed for etching boards up to 12 inches square. I bought this tank from DigiKey about 15 years ago, and it has lots of life still left in it. Let me explain. Boards are held vertically in the tank. There's a small external air pump which blows air down a plastic tube and into a plastic weight which lies on the bottom of the tank. Holes through the walls of the plastic tube along the last few inches allow air to escape and bubble up through the liquid. The streams of bubbles agitate the liquid and make sure the solution near the copper surface is kept fresh. At this end of the tank, there's a small heater inserted inside a glass shell, which looks like a test tube. Like many chemical reaction, the etchant's reaction with the copper is very sensitive to temperature. A chemical change, which takes 45 minutes at room temperature, might take only 20 minutes if the etchant is heated up by 10 or 20 degrees. This apparatus is very convenient, but it's not essential. One could use a plastic tray and simply lie the board down inside the etchant. Pull the attached wire from time to time to shake the board and slosh the etchant around. In fact, that's how I used to do it before I bought this tank. It will take between 20 minutes and an hour for the etchant to work. The etchant of choice is ammonium persulfate. The standard plastic bottle holds 1 kilogram in powdered form, which is enough to make 4 liters of etchant. When it's first dissolved, the etchant will be clear. The chemical reaction converts the copper metal into copper ions in solution. The copper ions give the solution a blue tint. The etchant will get bluer and bluer as it is used. The bluer the etchant gets, the weaker its action. Once you find that it takes an exorbitant length of time to etch a board, it's time to replace the etchant. When it's time to dispose of old etchant, I throw a piece of bare copper wire into the tank and let it sit there for a couple of days. This will use up any remaining ammonium persulfate. Don't pour the old etchant down the drain. I pour it into old paint cans and let the garbage men take them away on hazardous material pickup days. Dispose of old etchant using whatever the appropriate procedure is in your community. I determine when the etching process is done by pulling the board out of the etchant and holding it up to the light. The last copper to react will be found either inside small holes, such as those intended for the pins of IC chips, or in large patches near the corners of the board. Both show up when looking at a light source through the board. Note that it's not necessary to remove every last bit of copper from a drill hole. The depression left in a partially etched drill hole will still be sufficient for centering a bit when it comes time to drill out the hole. When the etching process is complete, I place the board into a tray of fresh water. This is a convenient way to carry it to the sink, where you will wash it thoroughly. The hard scrubbing pad and the scouring powder will remove the green dust and the toner, and a lot of elbow grease. To reduce the amount of scouring needed, I sometimes use the edge of an X-Acto blade to scrape off the dust and toner. If done with care, almost all of the dust and toner can be scraped off this way. This isn't as risky as it might sound. You may already know from playing around with circuit boards that it can be pretty hard to scrape off a copper trace. This is a good time to prepare the non-copper side of the board to receive the silkscreen layer. The board is made from an epoxy resin, and transferring toner onto epoxy resin is a little easier than transferring it onto copper metal. The difference arises because copper, being a metal, conducts heat. The resin is an insulator, and any heat which is applied remains localized. Even so, it's worth making sure that the back is clean and free from grease. Once you've scrubbed the copper traces clean, turn the board over and give the back a good scrub with the scouring powder. Now for the silkscreen layer. If your printed circuit board design software allows you to print mirror images, you're all set. Otherwise, you'll have to transfer the layout of the silkscreen layer to some other program and mirror it there. It happens that 123 Express does not print mirrored images. That's not an oversight. Their business is making printed circuit boards. They hope you'll use their software and then email them the layout so they can manufacture the board. So, when using 123 Express, I copy the image of the bitmap of the silkscreen layer into a blank Word document and manipulate it there. I use Word's crop and resize controls to get the image to the correct size before reversing it. As with the copper trace layer, start by putting an arrow in the upper right-hand corner of a blank sheet of copy paper. Print the mirrored image of the silkscreen layer in the center of the paper. Use the outline as a guide to cut out another piece of blue toner transfer paper, slightly larger than the outline, and then tape it into place. Shiny side up as before. Then print the image a second time, this time onto the toner transfer paper. Use a pair of scissors to cut the outline out, and then tape it, shiny side down, onto the non-copper side of the board. Alignment is important. First off, if the board is a simple rectangle, make sure to orient it correctly. Few things are more aggravating than laminating the silkscreen and then finding out you applied it kitty-corner backwards. If you cut the board out accurately at the outset, then the toner transfer paper can be positioned simply by lining up the edges. You should easily be able to get the paper and board aligned within a ½ millimeter. You can also see through the board and toner paper if you hold them up to a bright light. Unfortunately, the alignment you get doing this probably won't be much better than a ½ millimeter. I always use printed circuit board stock, which is 1/16 of an inch thick. Obviously, if you use a thinner board, such as a 1/32 inch board, you might be able to see through better and to position the paper more precisely. In any event, for a silkscreen layer, 1/2 millimeter will be good enough. If your board is more than about 4 inches long or wide, you are going to encounter a different phenomenon. Printers don't print as accurately as you might think. Try it. A large layout, as printed, will not have exactly the same dimensions your design software says. Although the distortion will likely be less than a ½ millimeter, you'll still be able to see it. Furthermore, the process of taping and the distortion to which the toner transfer paper is subjected as it is pressed and pulled and heated in the laminator all conspire to the fact that the silkscreen layer will never be completely accurate. As before, for the blue toner transfer paper, the laminator's temperature should be as high as possible. I run the assembly through the laminator 4 times. I remove the tape after the first pass and then run it through 3 more times. For the silkscreen layer, I don't run the assembly through from the sides. After the board cools down to just warm, throw it into a tray of water. This should be clean water. If you use this tray to carry the board from the etching tank to the sink, then refresh the water before using it to soak off the paper at this step. As an aside, let me tell you this. If you delay putting the board into water, moisture in the air will eventually cause the paper to start separating from the board. You'll notice this as the paper starting to bubble up and away from the surface. Bubbles will start to form about 10 minutes or so after the laminating is complete. I always immerse the board in water before bubbles start to form. The risk is that the bubbling will cause stress inside the paper, which can cause a toner trace to split. It's best to get the assembly into water so that the entire piece of toner transfer paper reaches its detachment point at about the same time. Once the paper slides off and the board is left to dry, you have a completed board. I drill all the holes at this time using a bit which is 1/32 of an inch in diameter. The best way to drill holes is a Dremel tool with a flexible shaft. I've tried drilling holes many ways, including a drill press, and this way is the best, by far. The handpiece on the end of the flexible shaft allows you to hold the chuck just like a pencil. Wrap some paper towel around a scrap block of wood to use as a backstop. The paper towel prevents scratching the toner on the silkscreen layer while the board is being moved around. Drill out all holes, including those which are going to be enlarged later. The 1/32 inch bit is the perfect size for the pins on IC chips and for 22 gauge hookup wire. Even for holes which will need to be drilled out larger, it's helpful to drill pilot holes at this time. If you value your eyesight, wear safety glasses when you drill. After all the holes have been drilled, give the board a final washing to remove all debris. After it dries, you have a finished board. Here are several things to bear in mind. The toner which makes up the silkscreen layer is a plastic. Anything which dissolves plastic will also dissolve the toner and mess up the silkscreen layer. That includes acetone and flux remover. If you intend to use acetone or flux remover on the copper side, you'll have to take care to ensure that none of it leaks through holes onto the silkscreen. Even after you've soldered all of the components in place, there will still be holes for mounting bolts and such like. The best way is to hold the board horizontal with the silkscreen layer up and to dab the cleaner onto the copper traces from below. A possible alternative, which I've not tried, might be to spray the silkscreen with something like a conformal coating, which is resistant to cleaners. No amount of tinkering with the layout will eliminate the need for jumpers on a single-layered board. When I lay out a board, I enter the jumpers as if they were lines in the silkscreen layer. And that's how they get printed, and how they show up in the silkscreen layer as, well, lines. Obviously, this is a shortcoming of making single-sided boards, and it's not a shortcoming of the etching process itself. The silkscreen is printed in black and not in white, as is traditional. The company Pulsar, which makes the blue toner transfer paper, also makes a white mylar foil, which is similar to the green mylar foil. This white foil could be used to apply white dust onto the silkscreen toner. While this is possible, I've not tried it myself. Online electronic component stores may not ship ammonium persulfate to your region. If not, you'll have to buy it locally. That shouldn't be a problem. Any shop which sells electronic components, soldering irons, and prototyping tools will likely carry ammonium persulfate as well. I've made double-sided boards on just 2 occasions, so I have limited experience. The way I did it was to apply the toner and green foil to one side of the board first, in the usual way. Then, with one modification, I processed the second side. The modification was to tape another piece of green foil to the completed side while taping the second side's toner transfer paper in place. The green foil on the completed side will protect it while the toner is being melted onto the new side. No harm is done if a board with toner and green dust already applied is sent through the laminator covered by another piece of the green foil. Since the toner is already saturated with green dust, no more will be added. Of course, when affixing the blue toner transfer paper to the second side, it will be necessary to turn the temperature down. This means that the second layer won't have the advantage of maximum temperature when it's being applied. However, the procedure did work, but as I've said, I've only done it twice. It's been my experience that the electronic circuits I've been able to design are not so complicated that a second layer is really essential. Ammonium persulfate is a big improvement over the etchant that used to be used, which was ferric chloride. Ferric chloride is dark brown. It's opaque. It was always a messy job trying to figure out if the etching process was complete. Furthermore, ferric chloride left indelible stains on hands and clothes. But you didn't need to worry about the stains it made on clothes because the material would be eaten away in a couple of hours. Ammonium persulfate doesn't leave stains. That's the good news. The bad news is that it still eats clothing. The difference is that the holes don't show up for about a week. I've seen reports on the internet where people claim to have used toner transfer paper with a household iron, and I mean an iron used to iron clothes instead of a laminator. A household iron did not work for me. In fact, it was that failure that convinced me to buy a laminator in the first place. A household iron has enough temperature. What's missing is the pressure. One simply cannot press down on an iron with enough force to complete the transfer onto the copper. Laminators can be purchased at Staples, Best Buy, or from any number of online stores. That's all for today. Thanks for watching. Best of luck with your boards. See you next time.